Hello, I'm Patrick Murphy. This is Quantum Shock Absorbers here in my hand. Welcome to our factory. This is where we actually manufacture the damper in West Sussex, and you'll soon see how to revalve one.
Right, so the first thing we're going to do is slacken your spring off. So the lock ring's nice and easy. Pat's already loosened that off for me. You just wind that back. And platform, wind that back as well. I don't know how much preload you've got on here, but probably an inch preload, if that.
Yeah, good that, I should think.
A few turns in. I should have measured that.
It's got a lot of weight to carry.
We'll fast forward through this bit.
Yep. Right, that's going to come loose at the top now, so I can push the retainer down, and that's exposed this wire clip, which, if I hadn't cut my thumb open, I might just be able to get over it.
Do you want to take that?
No,
yeah.
Yeah. I managed to chop off my thumb off with a brake facility, as you do. So the spring just comes off, just like that. Which leaves you with the bare damper. A slot ring, because we're going to catch some oil in this in a minute when we put that together. That goes over the top. And you need a pin spanner. Now these here with 3 pins, which we can sell you, obviously. And if the O-ring's a bit dry, you might just need to lock it back and forth a couple of times. Obviously in other videos I've pre-prepared that, so I don't have to do it. But
this is real life.
This is real life. So that just comes undone. You notice it hasn't gone through the air because the gas chamber's captive down in there, so you can take it apart. We haven't let the gas out, the gas is still in there. You just pull the shaft out, drain off any oil, and that's the business end of the damper there. So I'm going to move it to another vise, if you want to move your camera. 3/4 inch socket, take that nut off, try not to drop it, that can go behind me, and I'll talk you through the bits of the damper. So first bit you're going to see, that is the clamp washer. It's on the rebound side of the piston. So next you've got the rebound shim stack. Typically we'll put 4 shims on there, and there are 4 shims on this damper too. Piston, in this case it is symmetrical, but we do designs where you've got a smaller port on one side, usually on the rebound side. Bump stack. Now, this particular damper's got a bleed shim, which just spaces the main shim stack away from the face of the piston, so there's an amount of bleed before the shim stack starts to deflect. And finally, you've got the top out plate just there, which I won't bother to remove because I don't need to. That's the bits of the damper. So, I've laid the shims out on the table with the bump stack, the piston, the same way up that it came off of the shaft. Only because if we weren't dealing with the symmetrical one, that would be important. You don't want to forget where you are. And then the rebound stack, and as I've already showed you, you've got the clamp ring and the nut here. Now, we've measured these up in advance. I've got 6 thou and 10 thou shims here with a 6 thou bleed shim. And then on this side, we're a lot stiffer. We've got 15 thou shims mostly on this side. We're going to stiffen up the damper, so we've put a thinner bleed shim in there. We've put thicker bump shims in, and we've changed one of the rebound shims, and we use a digital caliper just to measure everything as we put it on as you go. So let's put the damper back together. First thing that's going on there is the bump stack. Bleed shim that I mentioned, that goes on next. We have the piston, again being careful to put it on the same way around if it was different. The rebound stack goes on there, and then finally the clamp ring and the lock nut. The lock nut we torque up to 25 pound a foot. I can't remember what that is in Newton meters, so that'll just have to flash up on the screen. There we go, that's now ready to go back in the damper. So I'm going to top up the damper. The oil goes just below the threads that you can see inside the top of the damper. And then piston, make sure the adjuster's open, makes life easier. Goes in there, with a bit of a circulation, you just stroke it down and then come back out. Normally, especially with the motocross dampers with the bleed shim, the second time you push it in, that is as much as you're going to need to do. If it's a stiffer damper, if you don't have a bleed shim, you're probably going to be stroking it in and out a few times just to make sure you've got all of the air bubbles out of the damper. And push the piston down. Now, piston of the damper is just about here, so I just need a little bit of a gap between it and the shaft bearing. Because what's going to happen when we screw the shaft bearing in just a moment, I'm just taking this O-ring off. When I screw the shaft bearing in, that's going to displace some oil, and you're going to be able to watch the shaft come back out. There it goes, it's coming up now. That's stopped, and now we're going to be pushing the floating piston down a bit with the displaced fluid until you're just there. Take off the slot ring. We're going to back off the shaft bearing a couple of turns, and I'm going to airline the oil out of there. Unfortunately, the airline's off camera, so I'll go do that over here and come back. So off camera, I've just airlined any oil out of there. It tends to get trapped between the threads. As you saw as I was putting it together, there's an O-ring down the bottom of the shaft bearing. So you airline the oil out, and there's a little O-ring, that just goes over there. Any residue, that will stop it coming out of the shaft bearing, hopefully. Then we tighten it back up. And wipe it down. So at this point, we can dyno test the damper and just check that everything's okay and make a record of where the valving is. Right, so what I'm going to do now, this is the dyno, obviously. I'm going to tape on a thermometer here so that we can actually read out the temperature of the damper as we're doing the dyno test. Getting a little bit tied up, obviously. I could have made that look much easier. I just chose not to. There we go. So that will now be read out while the computer's operating, the dyno, and we'll know what temperature that the damper's running at. At the moment it's at 31 degrees, so I'm just going to check the settings. We're going to 12 clicks of maximum stiff. That's in the middle of the range. Just means that everything's consistent. Any tests that we did before, we can compare it to it because it'll be at the same adjuster position. So 12 clicks, and I can now tell that to go. I'm going to do 10 strokes and output a graph, which I can now save. And what bike is this?
RM465 Suzuki.
So that's output the dyno graph, and for the sake of while we're here, what we're going to do now is I'm going to run it up to 45 degrees and we'll see just how much it drops off, as I believe Pip has told you we've done before. So, set the temperature control on. And you're probably going to cut the video at this point and come back to degrees. It shouldn't take too long to get there, but the amount of fade is pretty small. They don't change a huge amount.
closer now to what it was before.
Yeah.
I think we lost about half a kilo. As it got hot.
I would expect it to be.
That's amazing.
So what do the colour lines on the graph indicate?
So on this one, the red line, that is the active test. That's what it sees at the moment. The blue line is as it was just now. You expect them to settle after you put that together. And you also expect, as we're doing now, for it to just creep in a little bit as it gets up to operating temperature. We find that it runs at about 45 degrees. So once this gets up there, this will take longer than it would do to get to operating temperature on the bike, partly because shorter stroke, it's not going to be travelling as fast as it would do on the bike. But nonetheless, what we have ultimately is the performance of the damper at operating temperature. Beyond that, I haven't ever seen on Dyno fade any further, but we're not subjecting them to the punishment that we get on the bike. The final bit of the puzzle is to put the spring back on, which is as simple as dropping the spring on with the spring retainer. The clip goes over the top. If my thumb survives, I should be able to get that on. Yeah, that's right, I don't need to use my thumb. There we go. So that's snapped in there. And then we're going to wind the spring back up by hand. No, it's not. A bit of dirt into the flip. Again, I can make this look easier too, couldn't I? That's better. So wind the spring up by hand, and then you can either have measured the spring beforehand and we can reset it the same preload, or if we're going to be installing it on the bike with Pip later, he'll talk you through how to preload your spring.
Okay.
Back to the customer.